Hi everybody, welcome back. Today's lesson we are going to talk about how to utilize the calculator and finding some trig functions. We're also going to solve some triangles using this idea of trigonometry. Alright, let's get started. I have my calculator ready to go. You are going to need a calculator today. It's really important that you practice with me so then on assessments you are not lost on what buttons to use and what to press because unfortunately on those moments during the exam we can't really help you because that's when we are assessing to make sure you understood it. Okay, so please be prepared with your calculators. All right, let's look at, I'm going to split my screen so you can kind of see. Ooh, sorry. Here we go. Okay. So what you're going to notice is it says use a calculator to evaluate the trigonometry functions round to 4 decimal places. And the first one is sine of 25 degrees. So first thing I want you to do is press the mode button on your calculator and make sure you see that degree. If you don't, go ahead, get on the degree and just press enter. Now mine is in degrees, so I'm going to quit out of here. And then I'm just going to go ahead and type sine. Sine is right above 7, 2 buttons above 7. So sine of, and then 25, close it up and press enter. It did say round to 4 decimal places, so I'm going to cut it off after the 6. And since it's a 1, 6 will stay. So it's 0.4. Oh, my screen. Hold on one second. Alright, I fixed my screen, so it's 0.4226. Alright, so cosine of 45, we're going to press the cosine button. 45 degrees, enter. Sometimes you don't have to close a parentheses and it'll give you the answer. So our answer is 0.7071, and then it's a 0, so the 1 stays. Tangent of 11, so we have tangent of 11 degrees, close it up, enter. We have a 0.1943, but then there's an 8, so that 3 will bump up to a 4. So 0.1944 is our answer for that. Now we can also solve our reciprocal functions on the calculator, but it takes one extra step. So we don't have a button for cosecant, secant, and cotangent. You won't find it on the calculator. So what we have to do is we have to rewrite this. Well, we know that sine is a reciprocal of cosecant, so we have to write it as 1 divided by sine of 76 degrees. And then we're going to get the answer. So I have to do 1 divided by sine of 76 degrees, close it up, and press enter. And my answer is going to be 1.0306. Now secant of 31 degrees, I have to type it as 1 over cosine of 31 degrees. So I have to use a reciprocal function. We have 1 divided by cosine of 31 degrees, close it up, enter, and the answer is 1.166126. Okay. And then it's 3, so I don't have to bump it up. Cotangent of 99 degrees is going to be 1 over tangent of 99 degrees. And so I'm going to do 1 divided by tangent of 99, close it up, and we are going to get a negative number, negative 0.1584. Since it's an 8 after the 3, we bumped it up. Alright, so that's how you would find these estimations on the calculator. So let's continue. I'm going to put my calculator away for a minute, and I'm just going to do full screen. My calculator's still out, but so have yours out as well. Now it says, we learned that if we know 2 sides, we can use Pythagorean's theorem to solve for the third side. And we also talked about angles and how if we have 2 angles, we can find the third angle because we know they add up to 180. But the problem is if we have one angle and one side, what do we do? And the only option we have is we have to use trig to figure it out. So those are the situations we're going to run into today. So let's look at example 3. It says solve for x round to the tenths. Okay, so I have an angle here, so I'm going to be looking at everything from here, from 32 degrees. And I know that 32 across from that is x, and this is my opposite side. Okay, and that's what I'm trying to find. Now, across from 90 is 25, so this right here is my hypotenuse. So the idea is, well, what trig function has opposite and hypotenuse? Well, let's see. We have SO, we have SOHCAHTOA. So the one that has the opposite and the hypotenuse, the O and the H, is sine. So we're going to be using our sine function. Okay, so here's how we write it. Sine of the angle, which is 32 degrees, equals the fraction, opposite side first, x, divided by hypotenuse, which is 25. Once we have the setup, it's almost like finding the missing side. We need to figure out what this is, so we just have to solve it. So what we do is we multiply both sides by 25 to get x alone. X equals 25 times sine of 32 degrees, and we type this into the calculator to see what x is. So here it is. Oops, sorry. I'll move it to the side. Clear your home screen. We have 25 times sine of 32 degrees. Close it up, and our answer is 13.2 because it wanted it to the tenths. So 13.2 is our length for that opposite side. Okay, so let's try this one more time. Now it says solve for x, round to tenths, then solve for angle A. So let's solve for x first. So here's our angle, 41 degrees. So you can never look at it anything from 90 degrees. It has to be the acute angles. So since they're giving me angle B, which is 41 degrees, I'm going to look at the triangle from there. Now opposite side is right here, but I don't have any information for that, so I'm not going to label it. But across from 90, which is right there, x, is my hypotenuse. And then right next to me is my adjacent. Okay, so it looks like I'm using adjacent and hypotenuse. And if I look at SOHCAHTOA, I see adjacent here and hypotenuse here. So I have to use a cosine. Cosine of the angle, 41 degrees, equals adjacent 5 over the x. Okay. Now, a lot of people will think, oh, I need to divide by 5 in order to get x alone, but the problem is x is in the denominator. So it's a two-step problem. We're going to go ahead and multiply by x first on both sides. These x's cancel. We're left with x times cosine of 41 degrees equals 5. We still have to get x alone, so last step is divide by cosine of 41 degrees. Divide by cosine of 41 degrees, and now x is alone. So x equals 5 divided by cosine of 41 degrees. So it's a little bit harder than what we did in the first problem because it's a two-step problem. X is in the denominator rather than the numerator. All right, so I'm going to type this into my calculator, handy dandy calculator. Let's move it to the other side so you can see. All right, so we have 5 divided by cosine 41 degrees, close it up, and enter. So 6.6. So x is 6.6. But that wasn't all that they wanted from us. They then wanted us to solve for angle A. So they want us to find this angle. So we have to use the idea of all angles in a triangle add up to 180. Well, we know that the right angle is 90 degrees. We have 41, so we just need to figure out what this missing side angle is, which is angle A. So let's see. We have 41 degrees plus 90 degrees plus angle A has to equal 180 degrees. So we just got to do some algebra. Add them up. We get 131 degrees plus angle A equals 180 degrees. And if we subtract 131 degrees to the other side, we are going to get 59. Oh no, that's not true. 49 degrees. 49 degrees. There we go. And that's our angle A as well. So we have answered all of their questions. Awesome job. All right, let's look at the last problem that we have. Now, this chart that you see is kind of to give you an idea of what you can do. For example, if you know that there are two sides, hey, use the Pythagorean theorem. But if there aren't two sides, so the answer is no, there aren't two sides, circle the reference angle and use trigonometry, and then you might have to use the Pythagorean theorem to find the other side. So it's a two-step problem. It's a little bit harder. Alright, so let's look at this problem. It says using the triangle, solve for the following, round to the tenths. Okay, so we have to find side A, side B, and angle B, and we'll do it in that order. Okay, let's label everything. So across from angle A is side A. Across from angle C is side C, and across from angle B is side B, which is already given to us. All right, so let's solve for A. In order to solve for A, we need to use trigonometry because we have two sides missing. So if we have two sides missing, we have to use trig. I can't do Pythagorean theorem. So I'm going to say angle A is where I'm looking at everything from. My eyes are right here. Okay. And across from me is A, which is my opposite side. Okay. Now, I don't know what the hypotenuse is, but I do know my adjacent side. And now I can set up my trig function because opposite and adjacent is TOA. So I can use tangent. Tangent of 61 degrees equals opposite side, which is A, over the adjacent side, which is 12. Now I can solve it. Multiply 12 on both sides. 12 times tangent of 61 degrees equals A. All I have to do is type that into the calculator and get an estimation. Let's move that to the other side. All right, so we have 12 times the tangent of 61 degrees. Close it up. There's our answer. Did it say up round to the tenths? Okay, I just wanted to check. So 21.6. So A is 21.6. Done with one side. All right, 21.6. All right, now once we know that A is 21.6, now we have a triangle with two sides given to us, and the hypotenuse was missing. So, given what we've done earlier in this unit, we can go ahead and run the Pythagorean theorem. A squared plus B squared equals C squared. A is 21.6. B is 12. And C is what we're looking for. So I'm going to type this into the calculator. 21.6 squared is 446.56. So 66.56 plus 12 times 12 is 144. So now we get to add those numbers. So let's add 144. We have 610.56. And last step is to square root and see what we get for our answer. Okay, so what is our answer? Square root, second square root of this answer that we had before is 24.7. So our answer is 24.7. 24.7. And then the last thing we have to find is angle B. It's a capital letter, so I know it's an angle. We have angle A is 61. We know angle C is 90 degrees, so we just have to figure out what angle B is. Well, we know that 90 plus 61 plus angle B is going to give us 180 degrees. So when we add these two up, we get 151 degrees plus angle B is supposed to equal 180 degrees. If I subtract 151 to the other side, angle B is going to equal 29 degrees. 29 degrees. And we call this solving the entire triangle because now we know everything about the triangle, all three angles, as well as all three sides. So great job on solving the triangle. See you in class.